All right, this is Mr. Trutna. This is Math 2. We're going to go over Unit 8, Worksheet 5. We're not going to do all the problems. We're just going to do the ones that were circled that I assigned to you guys. If you want to do them all, that is fine, but I'm only going to do the ones that were assigned. Okay, so for each one of these first problems up to number 18, we're going to be simplifying radical expressions. Then we're going to circle the capital R if our answer is a rational answer, and we're going to circle the IR if our answer is an irrational number. Okay, so in number 2 right here, we have 2 square root 5 plus 6 square root 5. So the idea is when you are adding, you have to think like terms. Terms will be considered like terms if they have the same, if the radical has the same radicand. Okay, so then the idea is you think this. You go outside plus outside, which is 2 plus 6, and then you leave the radicand as is. So your answer to number 2 would be 8 square root of 5, and that answer is irrational. An answer, if you have a radical for an answer, and if the radicand, the number inside the radical, is not a perfect square number, then the answer is irrational. Okay, number 3, we have 5 square root 13 minus 7 square root 13. So these are like, we think like terms, and they're like because of the 13s. So then the rule is you go outside minus outside, which is 5 minus 7. Those are the outside numbers. Then you leave the radicand as is. 5 minus 7 is negative 2. Leave the radicand as negative as square root of 13. That number is irrational. The reason why it's irrational is because 13 is not a perfect square number. Okay? Number 4, 4 square root 11 plus, and the way I'm going to say this is 1 square root 11. So keep in mind that if there is no coefficient number in front of the radical, it's a 1, it's implied. So these are like each other because the 11s are the same, the radicands are the same. So we go outside plus outside, and then we keep the radicand as is. 4 plus 1 is 5, square root 11. 11 is not a perfect square number, so this answer is irrational. Okay, number 5, when we're adding up groups of numbers, the first thing that you want to do before you attempt to add, I'm going to zoom it in just a little bit so you can see it here, is you want to rewrite the problem so that there are no grouping symbols at all. Okay, so you think to yourself, you go, all right, what number is in front of this grouping symbol? It's a 1. What number is in front of this next grouping symbol? It's a positive 1, a plus 1. And if I were to distribute the 1, and if I were to distribute the positive 1, what would my problem look like without the grouping symbols? 1 times 3, 3. 1 times positive 6 radical 17 would be 6 radical 17. Positive 1 times 4 is positive 4. Positive 1 times positive 2 radical 17 is 2 radical positive 2 radical 17. Okay, so in this problem, rewriting it without the grouping symbol doesn't change it at all, but it's always a good idea to rewrite without grouping symbols. Okay, once we have no grouping symbols, now we think like terms. So I take this 3, and I think of it as like with the 4. So I'm going to associate the 3 and the 4 together, and that's going to give me a 7. Then I'm going to go plus, and then I'm going to associate the 6 radical 17 together with the 2 radical 17. Those are like terms. So what do I do there? I go outside plus outside, so I'm going to go 6 plus 2, and I keep the radicand as is. So that would give me a positive 8. So I have 7 plus 8 radical 17. That would be my answer. Some students want to add this 7 to that 8, but you can't because that 7 is missing the square root or radical 17 to make them like. This would be irrational because the radicand, the 17, is not a perfect square number. Okay, number 17, or number 7, we have grouping symbols, so we want to rewrite the problem without the grouping symbols. So once again, you go, okay, I have a 1 in front of that grouping symbol. In front of this grouping symbol, I have a negative 1. And then you would say, all right, so if I distributed the positive 1, what would that grouping symbol become? 3 plus 7 square root of 2. Then, if I distributed the negative 1, what would this next grouping symbol become? Negative 1 times negative 5 would make that positive 5. Negative 1 times positive 7 square root of 2 would make that a minus, or a negative 7 square root of 2. So you can see rewriting the problem without grouping symbols actually changes the signs of the second grouping symbol. Now I think like terms. So I have this 3, I have this positive 5. I can combine those together. I can associate them in my mind. I don't have to write it down. 3 plus 5 gives me an 8. Then I can group the positive 7 radical 2 together with the negative 7 radical 2 together. And if you notice, they're the exact same. And one is positive and one is negative. So that means they will cancel each other out. And that is your answer, 8. 8 is a rational number. Anytime you get a whole number, it's considered a rational number. Okay? Number 8, first thing I would want to do in this problem is probably I would rewrite it and put it in the order of like terms. So I'm going to take this 2, I'm just going to move numbers around. Next I'm going to write a minus 2. Then I'm going to write a plus 8 square root 6. And then I'm going to write a plus square root 6. This isn't necessary, but it's helpful so that when you group the numbers together, you're going to be able to see when you have like terms. So putting 2 and 2 minus 2 together, well, that's just going to be 0. They cancel each other out. Then when I add up 8 squared to 6 plus, now once again, if there's no coefficient in front of the radical, it is a 1. So then I go outside plus outside, 8 plus 1, and I leave the radical alone. So my answer is 9 radical 6 for number 8. That is an irrational number because 6 is not a perfect square. Okay? All right, now we get down to number 12, 13, 16, and 17. And these problems we're multiplying or dividing. Okay, multiplying or dividing, you don't worry about like terms. All you do is in multiplying, you go outside times outside, so negative 2 times 7. And then you put the radical symbol, and then you go inside times inside. There's no worry about like terms for multiplication. Then you simplify it. Negative 2 times negative 7 is negative 14. Radical symbol, 5 times 3 is 15. That's your answer to number 12. That is an irrational answer because 15, the radicand, is not a perfect square root. Okay, same idea with number 13. 4 outside times 2 outside, we put the radical symbol. 12 inside times 3 inside. Okay, and I simplify it. 4 times 2 is 8. 12 times 3 is 36. Okay. Now that is not your final answer, and the reason is because 36 is a perfect square root. So if I were to rewrite this, and you should, you have to, you have an 8, but now the square root of 36 is just 6. So your final answer is 8 times 6, which is 48. That answer is rational. Whole numbers are considered rational numbers. Number 16, 7 square root of 5 times 2 square root of 5. So the rule is we go outside times outside, 7 times 2, and then we put the radical symbol inside times inside, 5 times 5. 7 times 2 is 14, so when I simplify this problem, I get 14. I put the radical symbol. 5 times 5 is 25. Okay? 25 is a perfect square number. You should recognize that, which is 5. So this problem becomes 14 square root of 25 is 5, and then you multiply the two values together. Your answer is 70. That is a rational number. Okay? All right, number 17, we're dividing in this problem. So when we divide, now first of all, there is no number in front of the square root of 3, so that's a 1. So you divide in the same manner you multiply. So you go outside divided by outside. You're dividing instead of multiplying. 7 divided by 1. And then you're going to put the radical. And then you go inside divided by inside. 75 divided by 3. Okay? Simplify. 7 divided by 1 is 7. Put the radical symbol. 75 divided by 3 is 25. Okay? Now, if you can't simplify this any further, that's your answer, but you can simplify this. Square root of 25, that is a perfect square number, and the square root of 25 is 5. So then 7 times 5 is your final answer of 35. That is a whole number. Number 17 is rational. Okay? All right, moving over to the back side, we have number 23. Number 23 says, can the sum of two irrational numbers be rational? So what this is saying is, if you think of an irrational number, like the square root of 5, and you take the sum, that means you add it to another irrational number, like let's say the square root of 7, these are two irrational numbers, can these ever equal to be a rational number? So this is saying, can we ever get it to be equal to a rational number? Okay. Now the answer, and then you have to give an example. So this is a yes or no question, and then you want to give an example of, is the answer yes or is the answer no? Okay. So here's how you want to think about it. So most people would say no. You say no, there's no way you could add those up to make a rational number. Okay, you can't even add those up. And even if I made them the same, like 3 square root 5 plus 2 square root 5, that would be 5 square root 5. Well, that radicand is not a perfect square number, so there's just, it's impossible, because this number will never change. Okay, so the answer is, can the sum of these two rational numbers ever equal a rational number? The answer is no. It cannot happen. No. Okay, here's an example. 3 square root 5, which is irrational, plus 2 square root 5, which is also irrational. Well, that equals 5 square root 5, which is irrational. Okay, number 24. Can the product of two irrational numbers be rational? So in other words, if I took, let's say, these two irrational numbers, product means that I multiply them together, that would equal the square root of 35. Can I make this answer rational by multiplying two irrational numbers together? Well, that right there is no, because that's an irrational, and the product times another irrational, that's equal to an irrational. Okay? However, if we looked at these numbers here, let's say I took 3 square root of 5, which is irrational, and I multiplied it by 2 square root of 5, that would be outside times outside, 3 times 2, radical, inside times inside, 5 times 5. So that would be 6 square root 25, but the square root of 25 is 5, so this is equal to 30. 30 is a rational number. So this is yes. You can take the product, you can multiply two irrational numbers. 3 square root of 5 times 2 square root of 5, we just showed that that's equal to 30, which is a rational number. Okay? Number 25 here. Oh, lights just went out. Okay, we're back on again. Thank goodness the government isn't shut down. All right, so we're going to use these numbers, any of these numbers. So if you notice, we have 1, 2, 3, that's a number, 4, 5, 6 different numbers. We're going to choose 2 of those numbers that when I multiply them, it is rational. And when I add the same 2 numbers, it is irrational. So I'm trying to find 2 of these numbers. When I multiply them together, it's equal to a rational number. Okay? And when I add them together, it's equal to an irrational number. So let's look at 5 and 6. So if I multiply 5 times 6 together, I get 30. 30 is rational. Okay, but when I add the same 2 numbers up, 5 plus 6, that's equal to 11. I want my answer to be irrational, but 11's rational. So choosing 5 and 6 is not the right choice. Okay, so I have to find 2 numbers here that I could multiply together. So I'm going to choose 2 square root of 6. I'm going to actually multiply it by the square root of 6. Now, when I multiply these out, once again, that 6 has a 1, so I go outside times outside, that's 2. I go inside times inside, that's square root of 36. The square root of 36 is 6, so this becomes 2 times 6, so that's 12. So look, 2 square root of 6, that's irrational. 2 square root of 6, that gives me a rational answer. Now I'm going to add these together. 2 square root of 6 plus the square root of 6. When we add, we go outside plus outside, so that would be 2 plus 1, and then we leave the radicand as is. So that is equal to 3 square root of 6. So I multiply them, it is rational. I got that. That was 12. And when I add the same 2 numbers up, I get irrational. 3 square root of 6 is rational. So 2 numbers that would work for this case would be those 2 right there. Okay? All right. Then what we want to do on the last one is we want to simplify and determine which expression is equivalent to 8 to x to the power of 5/4. Okay? So the way that you want to work out this problem right here is you're going to take the 8x to the power of 5/4 and